Sulfide mining. Since sulfide ores are often buried deep within the earth, miners use underground mining methods, such as shaft mining or room and pillar mining, to access these deposits. Open pit mining. For non-silicates like carbonates and halides, open pit mining can be used to access shallow deposits. Heap leaching. This method is often used to extract metals from sulfide ores, particularly gold and copper, where cyanide or other chemicals are used to dissolve the metal from the surrounding ore. Smelting. Non-silicate metals, such as copper, iron, and lead are often extracted through smelting processes that involve heating the ores to high temperatures to separate the metal from its ore. Uses of non-silicates. Iron oxides, hematite, magnetite. These are used as ores for iron and are essential in steel production. Copper sulfides. Chalcopyrite, bornite. These are important ores for copper, which is used in electrical wiring and construction. Gold and silver. These metals have been used for currency, jewelry, and electronics for centuries. Fluorite, used in the manufacture of fluorine, and as a flux in steel production. Carbonates. Calcite, dolomite. These are used in construction, for example, cement, and as agricultural lime to neutralize soil acidity. Advanced exploration methods. While traditional digging and mining techniques are still widely used, modern mineral exploration has adopted high-tech methods that make it more efficient and environmentally friendly. Geophysical surveys. These surveys use techniques like seismic, magnetic, and electrical methods to detect mineral deposits underground. This technology can help determine the size, depth, and composition of ore bodies before excavation begins. Geochemical analysis. Soil and rock samples are analyzed in laboratories for their mineral content. This helps identify areas with high concentrations of specific minerals. Remote sensing. Satellite imagery and drones are used to identify potential mining sites. These methods help track geological formations from above, making exploration more efficient and less intrusive. Mineral mapping. By studying satellite images and geological data, experts can map out mineral deposits and anticipate where to dig. Advanced software and AI are increasingly used to predict mineral locations with high precision. Environmental and ethical considerations. With the increasing demand for minerals, particularly those needed for electronics and renewable energy production like lithium, cobalt, and rare earth elements, it's critical that mining operations take environmental sustainability into account. Reclamation. After mining operations, sites are often reclaimed to restore the land to its natural state. This includes replacing topsoil, replanting vegetation, and ensuring the water table is restored. Pollution control. Mining often involves toxic chemicals like cyanide or sulfuric acid, so environmental regulations require companies to safely manage waste materials and minimize pollution. Fair mining practices. Ethical mining is also important, especially in developing countries. Companies are increasingly expected to ensure safe working conditions, fair wages, and to avoid exploiting workers or damaging local ecosystems. Absolutely. Let's dive deeper into various aspects of mineral exploration and extraction, particularly focusing on the further nuances of both silicate and non-silicate minerals. We'll explore their origins, industrial uses, mining techniques, and the emerging technologies involved. Detailed exploration of silicate minerals. Origin and formation of silicate minerals. Silicates primarily form from cooling magma, or the weathering of pre-existing rocks, making them some of the oldest minerals on Earth. The formation processes include igneous formation. Most silicates are formed from the cooling and crystallization of molten rock magma that solidifies underground intrusive, or on the Earth's surface extrusive. Examples include quartz, feldspar, and mica, which crystallize as magma cools. Metamorphic formation. Silicate minerals can also form from the alteration of pre-existing minerals under high pressure and temperature conditions. This can lead to the creation of new silicate minerals such as garnet or the transformation of feldspar into more stable minerals. Sedimentary formation. Silicates can accumulate in sedimentary rocks when weathering and erosion break down larger rocks into smaller particles. These sediments can form new silicate minerals over time. Geological environments and occurrence. Silicates are found in many different geological environments, and their occurrence is closely tied to the type of rock they form from. Here are some common silicate environments. Granite and basalt. These are the most common types of rocks that contain large amounts of silicate. Minerals like quartz and feldspar. Granite is often used as a construction material, while basalt is commonly found in volcanic areas. Sandstone, a sedimentary rock that is largely composed of silicate minerals, like quartz. This mineral-rich rock is used in construction, especially in making concrete. Metamorphic rocks, silicate minerals, like mica and garnet, form from the transformation of rocks under high pressure and temperature. These minerals are often used as gemstones or as industrial abrasives. Mining and extraction of silicates. Silicates are relatively abundant, but their extraction depends on the form they are found in. Let's examine some of the typical silicate mining processes. Open pit mining. This is the most common method for extracting silicate minerals that are near the surface. Large-scale excavation is used to access rock layers containing minerals like quartz, feldspar, or mica. Placer mining. This method is often used for minerals like quartz that have been weathered and transported by water. Miners use water to wash away soil and other debris, allowing the silicate minerals to be collected. Crushing and grinding. Once extracted, silicate minerals are crushed and ground into fine particles, particularly for use in construction materials, for example, crushed quartz in concrete or for glass manufacturing. Industrial applications of silicates. Silicate minerals have diverse uses across multiple industries. Glass manufacturing. Silica from quartz is a key ingredient in glass production. It's used to make everything from everyday glass containers to specialty items like fiber optics. Ceramics and pottery. Feldspar and kaolin, a clay mineral, are essential in the production of porcelain, pottery, and ceramics. Electronics. High-purity quartz is used in electronics for components like semiconductors, as well as in the production of solar panels. Detailed exploration of non-silicate minerals. Origin and formation of non-silicate minerals. Non-silicate minerals are categorized into different groups based on their chemical composition and crystal structure. Here are the main categories. Oxides. These minerals contain oxygen and a metal element. They typically form when metals react with oxygen. Common examples include iron oxide, hematite, aluminum oxide, corundum, and copper oxide, cuprite. Oxides form in a wide range of environments, including sedimentary, metamorphic, and igneous settings. Carbonates. These are formed from the reaction of carbon dioxide with minerals. Carbonates are most commonly found in sedimentary rocks, where they form through chemical precipitation from water. Calcium carbonate, calcite, and magnesium carbonate, dolomite, are the most common examples. Sulfides. These minerals contain sulfur and a metal. They usually form in hot, hydrothermal environments or in areas with volcanic activity. Examples include pyrite iron sulfide and chalcopyrite, copper iron sulfide, which are both important ores of copper. Halides. These include minerals like fluorite, calcium fluoride, and halite sodium chloride, which form through evaporation in saline environments. Native elements. These minerals are pure forms of elements such as gold, silver, and copper. They are formed in various environments, from volcanic activity to meteorite impacts. Geological environments and occurrence. Non-silicate minerals are often found in specific environments based on their chemical properties. Sulfides often found in association with volcanic rocks, hydrothermal veins, and ancient volcanic sedimentary rocks. They are commonly extracted as metal ores, such as copper, lead, and zinc. Oxides found in environments where metal oxidation occurs, such as in desert or arid regions. Hematite and iron oxide is a primary source of iron ore and is often extracted from sedimentary rocks. Carbonates. These minerals are frequently found in sedimentary environments, especially in limestone and dolomite deposits. Native elements. Native metals like gold, copper, and silver are often found in veins and rocks or in placer deposits and riverbeds. Mining and extraction of non-silicates. Non-silicate minerals are typically harder to extract than silicates because they often form deep within the earth or are concentrated in specific veins. Here are some methods used for their extraction. Underground mining. Many non-silicate minerals, such as sulfides and oxides, are located deep within the earth and require underground mining techniques. This includes drilling shafts to reach ore deposits. Placer mining. For native elements like gold, placer mining is commonly used. Gold is often weathered from its original source and deposited in riverbeds. Miners use water to separate gold from lighter materials. Smelting. Once extracted, ores like sulfides and oxides are heated in a furnace to separate the metal from the surrounding rock. For example, iron ore is smelted to produce iron and steel, while copper ores are smelted to extract pure copper. Industrial applications of non-silicates. Non-silicate minerals play a vital role in many industries.